Hi everyone, welcome back to the next episode in this series of short AOAD lectures on design at a detailed system level. In this lesson, we will learn how to define attributes in classes. So, what's a class attribute? Essentially, it's a piece of data that's stored in a class. So, take this bank account class. It has 5 attributes: the account number, the account name, the balance, the overdraft limit, and the available balance. Now, in this account, you're allowed to draw more than your balance. That is the overdraft limit, and therefore, the available balance is the sum of the balance and the overdraft limit. In this lesson, we'll learn all about the various ways you can define attributes for your classes. Now, here is the formal syntax for attributes in UML. That looks pretty easy, right? Okay, everyone, don't panic. It really isn't all that complicated. Just let me break it down for you step by step. The first part of this scary looking thing says that we are defining the syntax for something called a property. And a property owned by a class is simply known as an attribute. So yes, everything to the right of that weird double colon equal sign gives instructions on the proper way to define an attribute. Everything in square brackets is optional, and there are actually lots of square brackets, like this. So in fact, the only thing that's not in square brackets, and is therefore compulsory, is the name. Everything in angular brackets is replaced by an appropriate value. So if I want to define a property that represents the account number of a bank account, then I could simply name it account number. Everything in single quotes is considered a literal, which means that it should be written exactly as given. As you can see, there are many literals in this syntax, and I will go into each one in turn. So now, let's take a look at the prop type, which represents the data type of the attribute. As you can see, it is preceded by a colon, which means that if I want to define that the account number is an integer, I would write it like this. The next thing we want to talk about is the visibility of the property. And the visibility is the visibility of the attribute. There are 4 possible values for the visibility. They are public, represented by a plus, private, represented by a minus, protected, represented by a hash sign, or package, represented by a tilde. So in this case, if I want the account number to be private, then I would put a minus sign in front of it. We will talk more about visibility in a later video. The next thing I want to talk about is this slash sign, and a slash denotes a derived attribute. So what is a derived attribute? It is simply an attribute that is computed from other information, for example, from other attributes. We might want to store a derived attribute for computational efficiency. So for example, if there's a value that you would access very often in your class, you might want to define a separate attribute for it, even though you can always compute the value from other attributes. So for example, we have the available balance attribute from the bank account class, and as was previously stated, the available balance is simply the sum of the balance plus the overdraft limit. However, to avoid having to recompute the available balance each time we want it, we can instead create an attribute for it, and we denote that it is a derived attribute using the slash. The multiplicity defines the number of elements in a collection. You've seen something similar to this when you define arrays in your low-level programming language. So for example, the attribute enrolled students is actually a collection of students, and we see that this collection contains between 0 and 30 students. We can also give a default value or values to an attribute, and in order to do that, we put an equal sign in front of it. So for example, the default value of the balance attribute is 0. Finally, there's the property string, and a property string states some property of the attribute. This might define some constraint on the attribute. So for example, I might say that the account name is a string, but it's not allowed to be null. Notice that there is an asterisk at the end of this definition, and an asterisk denotes 0 or more. So suppose I want to add yet another property string to account name, and I might do it like this. So this says that an account name is a string, it may not be null, and it must have at least 8 characters. And there you have it. That is the entire UML syntax for attributes. Achievement unlocked. And not only that, here is the second letter for the password, and the letter is D. D for Denmark. For all those people who are laughing about me giving you the D, haha, very funny, grow up. Remember that bank account class? So now I'm going to rewrite the bank account class using everything we've learned today. And you might end up with something like this. The bank account has an account number that's private and is of type integer. It has an account name that's private, of type string. It cannot be null and must have at least 8 characters. It has a private attribute called balance of type money with a default value of 0. An overdraft limit that's private of type money, and a derived attribute called available balance as denoted by the slash. That is also of type money. So what about this? The next account number, which is of type integer, and it's underlined. Underlining an attribute denotes that it is a class scope attribute, also known as a static attribute. In a class scope attribute, there's only one copy for the entire class, and you do not need to instantiate the class in order to call this attribute. Thank you all for watching. In our next lesson, we'll talk about how to define operations. Sorry for the slightly long lecture, so here's a potato.